Hello and welcome back, everyone. Into this video, we're going to talk about actuators. Now, actuators by far are my most favorite component in robotics, just because there are so many of actuators, and you can do so much with actuators. I feel actuators play a very important role in robotics overall, and that's what we're going to talk about here in this lecture as well. Now, so for everyone who doesn't really know what is an actuator, I'll give you a very simple example. You take the example of this small robot again. Uh, this thing. This is an actuator, the blue component, which is a motor. Okay. Any component which allows you to create any sorts of, motion or any sort of, actuation in any direction, that's an actuator. Okay. Let's take the example of, a robotic arm. For a robotic arm, the same motors, not the same motor exactly, but a motor is essentially going to allow the robotic arm to move forward and move backward. Okay. And that's what happens. And that's what helps a robot to, pick up things, move things around, and do a lot of all operations. Okay. So an actuator plays a very important role in all these aspects. So actuator is by far my favorite one. Let's dive into the chapter and have an understanding of actuators as well. Okay. So we are back onto our slide. Let's see what actuators are all about. Okay. And actuators are components used to control movement of robot. Okay. So when you want to control movement in a robot, that's when you use an actuator. Okay. Any sort of motion, any sort of movement you want to control, that's when you use an actuator. Pretty simple definition. So in the example of this robot, we want to control the motion which is going forward, backward, left, right. In that case, we use an actuator, a motor. Okay, that's what helped us. Actuators convert energy into motion, allowing the robot to perform tasks such as moving, lifting, and manipulating robots. Okay, manipulating objects. So if you want to manipulate something or move something or lift something, that's when you need an actuator, and that's the main key component over here. Types of actuators. Okay, there are several types of actuators which are used in robotics, including electrical motor, which are commonly used in robotics to provide rotary or linear motion to the robot joints. Okay, when you want to rotate something or move something linearly, that's when you use an actuator. There are several types of electrical motors used in robotics, including DC motor, stepper motor, and a servo motor. Okay, all of these things allow a robot to move in different direction, do things differently, and allow the motion to happen at a very continuous rate as well. Okay. Pneumatic actuators, quite a different name for a lot of people. You might have not heard the word pneumatic as well. Let me break it down for you. Pneumatic means air. Okay. Whenever you're talking about compressed air, okay, that's when you use pneumatic. Okay. If you have a pneumatic pump, it means it is running on air. Okay. If it's a hydraulic pump, then it means it's running on oil. Okay. Very important for you to understand and break down the difference, because if you don't know the difference between pneumatic and hydraulic, then it can be quite problematic. Okay. So you need to know what is exactly making the things move. Okay. When you talk about a syringe, okay, which doctors use, okay, they essentially have liquid inside. Okay. So any sort of liquid is again kind of an oil. Okay, that's basically a hydraulic, sort of like a hydraulic pump, which is pushing the liquid through a very thin line needle out from the entire body. That's why the pressure is quite high in a needle. Okay, a syringe. Okay, and that's why that is essentially a hydraulic pump or a hydraulic syringe. Okay, and any syringe without any oil or anything inside, then it's a pneumatic syringe. Okay, very easy to differentiate, but you should know what is the difference. They're commonly used in application where a large force is required, such as lifting heavy objects or moving any sort of heavy objects as well. Hydraulic actuators are pressurized fluids to generate motion. Okay, they're pressurized using fluids to generate any sort of motion. Kind of very important. They're commonly used in application where a large force is required, such as construction equipment. Okay, if you want to lift something, or whenever you go to a car wash, everywhere in a car wash they usually have a hydraulic lift. Okay, to lift up the car high so they can wash the car from the bottom. Okay, whenever you see all these hydraulic lift, there is a pump which is pushing and pressurizing the oil to push the oil down, and which is making that lift go up. Okay, and it's a very common phenomena which is used to make sure that whenever you're lifting a heavy vehicle, it's quite an easy task if you have a hydraulic, mechanism, so that, you don't need to apply a lot of force. That's quite an important thing. Then you have shape memory alloys, okay, or SMAs. Okay, very interesting. SMA materials can change shape when subjected to heat or electric current. Okay, I'll give you a very simple example of a shape memory alloy. Whenever you see a shape memory alloy, it's very easy to differentiate a shape memory alloy from a normal alloy, because what happens is when it comes in heat or electric current, then it starts to rigidify. Okay. Now, when I say rigidify, it will make its shape strong. Okay. Let's say you take an example of a dynamic dam. Okay. Dynamic dam basically is a dam which is automatically constructed whenever you have a very high or change in temperature or pressure. Okay. Let's take the example that you have a dam which you want to automatically stop the water if the water is getting too hot. Okay. Over there, you can use shape memory or SMA to allow it to block this dam or to block the water automatically. How? You basically need a sheet, okay, a sheet of metal, which is going to be built of SMA or shape memory alloy. Whenever the temperature is going to rise, it's automatically going to solidify. Okay, it's automatically going to solidify and it's going to make it like of a rigid wall. Whenever there is there is cold water going in, then it's automatically going to become like a normal sheet and it's going to allow all the water to go away. Okay, these sort of application, okay, where you need extreme amount of material science energy or technology to think out of the box. That's where shape memory alloy actually comes into picture. Very powerful tool. Not so much use these days because it's a little expensive, quite expensive actually, but extremely powerful. They're commonly used in small scale robotics such as medical robots, surgical robots which are there, or pneumatic or a small body implants which are there. They also use shape memory alloy to change the shape of metal when required. Now let's talk about importance of actuators. Actuators are important in robotics because they allow for robots to perform tasks such as moving, lifting, and manipulating objects. As I told you before, a robot, if it's not really doing any sort of manipulation, then it's kind of like not really a robot actually. So any sort of robot that you see, it needs to do some sort of manipulation, which proves that a robot is actually capable of helping the human in some sort of way or the other. There might be some robots which might be just not doing anything at all. I don't really consider them as robots. They are just simple like machine which are there. I think they quite useless. But any sort of robots that you see that are moving or that are doing something, they all require actuation. So actuators are kind of like a very important part of them. Actuators provide force and motion necessary to perform these tasks, and they're all essential for components in robotics as well. Okay, whenever you talk about robotic components, essentially actuators are the one which are majorly being playing a role. Okay, and if actuators fail, then robot kind of like is half paralyzed, I would say. Okay, let's say you take the car of this small robot. If the wheels are not rotating, then it's kind of like half paralyzed. The only thing that is working is the small display which is on the front, but apart from that, the robot is not moving at all. Let's take some examples of robot actuators. The first one is a DC motor, which provides a rotary motion at the robot joint. This is a DC motor, okay, the one that I'm spinning. Yeah, this thing. So this motor is essentially the one which is used when you talk about moving, or when you talk about making a motion. Okay, and this motion in particular is quite helpful when you want to perform any sort of action, or when you want to move from one point to the other, anything like that. Okay, that's when DC motors come into play. Then you have servo motors. So obviously, like a servo motor is this is a servo motor, but this is also a DC motor. A DC motor is the one which just doesn't really have a gearbox. So a DC motor with a gearbox is basically a servo motor. So this is both a DC and a servo motor. That's what this motor is. Then you have pneumatic cylinders for lifting heavy objects. Sadly, I don't really have a pneumatic cylinder in my room, which I can show. But pneumatic cylinder is the same that is used in car washes to lift up the car up so that you can, the people can wash the car from down. And it's a very commonly used cylinder as well. Then you have hydraulic cylinders used for, moving large objects as well. If you have opened the back of your car, there are cylinders which are there, which helps to lift the back door of the car for you. Okay. Those are essentially hydraulic cylinders. Quite a common thing to do. In conclusion, actuators are essential components of robotics, allowing robots to perform tasks such as moving, lifting, and manipulating objects. Of course, when you want to move a lot of things, when you want to do a lot of operations, and that's where, these actuators come into play. And there are several types of actuators used in robots, including electrical motors, pneumatic actuators, hydraulic actuators, and shape memory alloy, as I said. Understanding the different types of actuators and their application is essential for designing and building effective robotic system. Okay, you need to break it down. You need to understand how these components are working, and then you would have an idea. Okay, this is how, and this is what exactly is happening in a robot. And that's it for this chapter. Personally speaking, I think this is one of my favorite chapters to talk about any time of the day. Um, just because I think, actuators are such a important and crazy aspects of robotics, and they're so helpful in doing anything you want. I'm personally in love with actuators. One of my favorite topics, of course. I hope this becomes your favorite topic as well. And I hope you enjoyed today's lecture. Not a lecture, actually, a chapter. I'll see you all in the next one. Till then, happy learning and peace.